the right hand side of extends does not have to be an identifier. You can use any expression that evaluates to a constructor. This is often useful to create mixins, and you can check out the article about mixins, so you want to read this stuff. And here they give us an example, and we're gonna check out this example in the Visual Studio Code. So we're gonna go to Visual Studio Code, and we're gonna have two files, one with HTML extension and the other one with JavaScript extension. So in this file is gonna be named test.html, so I'm just gonna shift exclamation mark and then press enter. And for now I'm gonna type in script, and I'm gonna close it here, script. So in this I'm gonna put my source, and the source is gonna be the name of my JavaScript file, that in this case is gonna be test.js. So right now I have connected my JavaScript file to my HTML file. So right now in our HTML file we're gonna write this code, or we can just copy it. I'm gonna explain it, so we just grab it and paste it here. So here we have a class, song class extends class, and here the song class is the child class, as we saw it in the previous examples about the syntax of the class. So the syntax is class, child class extends, and this one is the parent class, and then you, and the set of curly braces is where you write your code. So here in our Visual Studio Code, so we have the song class is the child class, the parent class is just class. We open the curly braces and we have a constructor. Inside of the curly braces of the constructor, we are gonna cancel that lookup message, and that message is gonna be this string base class. So we put a semicolon at the end, we close the curly braces of the constructor, we close the curly braces of the class on class extends class, and now we're gonna open a new set of curly braces, and inside of that we're gonna have another constructor, but in the curly braces of this constructor we're gonna have the function called super. We ended up with a semicolon, and now we're gonna cancel that log a message that is gonna be the string derived class. Again, we close it with a semicolon, we close the curly braces of this constructor, and we close the curly braces of the set. So outside of that, since the child class is named song class, we're gonna use here the keyword new, and it's gonna be new song class. And again, you put parentheses at the end, and we save it with Ctrl S. Okay, so we save it, and now we go to our test HTML, just right click and we open it with live server, or you just press Alt+O. So it's gonna send us to this page. We just type in Ctrl+Shift+I, and there you have it. The strings that we are gonna get is gonna be, when we cancel that log, we're gonna get this string base class, and this is what we're getting here. And the second string is gonna be derived class, and this is the string that we're getting here. And easier, you can go to our Chrome developer tools and just copy this example, paste it, and you're gonna get the same. But also we're gonna get the song class here, and inside we're gonna have the prototype, we're gonna have the constructor, the classes, the child class is song class, and here we're gonna have more information. You have the prototype, and here you're gonna have even more information. So that is that for this example. While the base class may return anything from its constructor, the derived class must return an object or undefined, or a type error will be thrown. So here we have a different example. We have the class, parent class, inside of its curly braces we're gonna have a constructor, and this constructor is gonna return the number 1. So we close the curly braces of the constructor and we close the curly braces of the parent class. And now we're gonna cancel that log, and inside of the parentheses we're gonna pass in the new parent class. So the name is parent class. That is the reason that we have to use the keyword new and then parent class with parentheses. We close it with a semicolon. Here we're gonna get the parent class and this empty set of curly braces. The return value is ignored because it's not an object. This is consistent with function constructors. So we're gonna see it in the Chrome Developer Tools, but first of all, we have the class child class extends parent class, and again, this is the child class, this is the parent class. Inside of the curly braces, we're gonna have the constructor, and we're gonna return the number 1. We close the curly braces of the constructor, and we close the curly braces of the class child class extends parent class. So finally, we're gonna cancel that log, the keyword new child class, and then again we have to use parentheses at the end, and we're gonna get a type error. Derived constructors may only return object or undefined. So we can check out in our Chrome Developer Tools. So we can go here, clean it up with Ctrl L, or just press in the circle. So we paste it with Ctrl V, and here we have the parent class, but also we get the uncode type error. Derived constructors may only return object or undefined. So that is that. There is the error that we saw here, type error. But also we got the parent class, and an empty set of curly braces. And again, we have the prototype object, then we have the constructor class parent class. So we have all this information here. So that is that for this example. If the parent class constructor returns an object, that object will be used as the keyword des value for the derived class when further initializing class fields. This trick is called return overriding, which allows a derived class's fields, including private ones, to be defined on unrelated objects. And now we have subclassing build sense. Here we have a warning. The standard committee now holds the position that the building subclassing mechanisms in previous specs versions is over-engineered and causes non-negligible performance and security impacts. New built-in methods consider less about subclasses, and engine implementers are investigating whether to remove certain subclassing mechanisms. Consider using composition instead of inheritance when enhancing build sense. So here are some things you may expect when extending a class. And here we have, when calling a static factory method like promise.resolve or array.from on a subclass, the return instance is always an instance of the subclass. This one, when calling an instance method that returns a new instance like promise.prototype.then method or array.prototype.the map method on a subclass, the return instance is always an instance of the subclass. Instance methods try to delegate to a minimal set to primitive methods where possible. For example, for a subclass of promise, overriding the then function or the then method automatically causes the behavior of the catch method to change. Or for a subclass of the map object, overriding the set method automatically causes the behavior of the map constructor to change. However, the above expectations take non-trivial efforts to implement properly. The first one requires the static method to read the value of the keyword des to get the constructor for constructing the return instance. This means that in this array of elements p1, p2, and p3 chained to the map method as promise.resolve as an argument throws an error because the keyword des inside promise.resolve is undefined. A way to fix this is to fall back to the base class if the keyword des is not a constructor, like array.from method does. but that still means the base class is a special case. The second one requires the instance method to read the this.constructor to get the constructor function. However, know that this.constructor may break legacy code because the constructor property the constructor property is both writable and configurable and is not protected in any way. Therefore, many copy and built-in methods use the constructor's species symbol species property instead. And if you want to read more about this, we have the symbol data species, the symbol data species property instead, which by default just returns the keyword this, the constructor itself. However, the symbol data species allows running arbitrary code and creating instances or of arbitrary type, which poses a security concern and greatly complicates subclassing semantics. The third one leads to visible invocations of custom code, which makes a lot of optimizations harder to implement. For example, if the map constructor is called with an iterable of x elements, then it must visibly invoke the set method x times instead of just copying the elements into the internal storage. These problems are not unique to built-in classes. For your own classes, you will likely have to make the same decisions. However, for built-in classes, optimizability and security are a much bigger concern. New built-in methods always construct the base class and call as few custom methods as possible. If you want to subclass built-ins while achieving the above expectations, you need to override all methods that have the default behavior baked into them. Any addition of new methods on the base class may also break the semantics of your subclass because they are inherited by default. Therefore, a better way to extend built-ins is to use composition